Good morning, class. So, last time we were studying about the allotropes of carbon and we already discussed about the case of diamond. Okay? So, when we are talking about the allotropes of carbon, what we studied till this time, we studied about what actually the allotropes are, what are the crystalline allotropes and what are the amorphous allotropes, and then we studied about the crystalline allotropes, in which we are going to study about the diamond, the graphite and the fullerenes. Okay, and diamond already we discussed, so in today's class we are going to discuss about the graphite and the fullerenes. Okay, so when you see your book, NCERT book, that time you saw that basically what actually the allotropes are. Allotropes, it means when we are talking about something which is physically different but chemically they are same. Okay, it means when they are physically when they are physically different but chemically same. Okay, so when we are talking about the diamond, we saw that diamond actually has a three-dimensional structure. Each and every carbon atom of the diamond is attached with the nearest four carbon atom. Okay, so that's why the diamond is forming the three-dimensional structure, and because of this three-dimensional structure and each carbon atom is attached with the near four carbon atoms, so there is no free electron in the case of a diamond. So the two things we get as observation, that first is that diamond is very rigid and very hard in nature. Second thing is that because there is no availability of free electrons are there, so that's why jo diamond hai, that is the bad conductor of, this is the bad conductor of electricity. Yeah, you can say that this is working as a insulating property. Okay, so diamond is a insulator. Okay, now in the today's class we are going to discuss about the graphite. So when we are talking about the graphite has a layered structure. Okay, it has a layered structure, like you can see that this structure of a graphite, the one layer is here, the another one layer is here. So it is the sheet like structure present in the graphite, and in the case of a graphite, each and every carbon atom is attached with the nearest three carbon atom only. Okay, nearest three carbon atom only. Okay, but in the case of diamond it was attached with the nearest four carbon atom. Okay, so now when we are talking about the graphite, now here if we saw that one carbon is attached with the nearest three carbon atoms, so definitely there is one electron which is free. Okay, and how the valency of the carbon is balanced, because there is a one double bond between them, so that's why the tetravalency of the carbon is balanced in the case of a graphite. So because of this one electron free which is present in the graphite, so the graphite is a good conductor of electricity. It can easily pass the current through it. Okay, and because it has a sheet like structure, so the graphite is also soft. Okay, in comparative to the diamond, the graphite is soft because it has a sheet like structure, or you can say a hexagonal two-dimensional structure, and because of the availability of free electron, because each and every carbon atom is attached with the nearest three carbon atom only, so the graphite is also a good conductor of electricity. Okay, so you should know that major two differences between a graphite and a diamond is that diamond is very hard, graphite soft, and diamond is a bad conductor, graphite is a good conductor of electricity and current. Okay, now when we are coming to the third, that is a fullerene. So fullerene, the structure of the fullerene was given by the Buckminster Fuller. Okay, the name of that US architect. So so because of the Buckminster Fuller, these body like structures are called as the fullerenes. Okay, and these are also the carbonic compounds and allotropes of carbon, and they are in a cage like structure. It's like a ball. Okay, ball, you can see like ball. Okay, and you can see that these carbon are these fullerenes have a lot of carbon in them. So you can see that the first fuller is the C60. It means they have at least 60 carbon atom in them. Okay, so they are very highly packed to each other, and very complicatedly they are packed to each other, so that's why we are calling them as a fullerenes, and they are basically the ball like structure, and it was given by the the US architect Buckminster Fuller. So that's why the name of these compound is called as the fullerenes. Okay, so now we are doing the quick recap what we studied in that allotropes of the carbon. Okay, here already I told you what are the crystalline allotropes. So crystalline allotropes, it means that it has a particular shape. Okay, crystalline means that have a shape, and amorphous it means do not have any particular shape. Okay, so crystalline में three examples are coming, like diamond is coming, graphite is coming, and fullerene is coming. Fine. Now when we are talking about the definition of the allotropes, as I already told you, that which have the same physical properties but which have the different physical properties but chemically they are same, that is called allotropes. Okay, so if you want to read it, you want to write it, you can. Allotropy, it is the existence of element in more than one form having the same chemical property but different physical properties. The various forms of an element is called as the allotrope. So you should know what is the definition of allotropes and allotropy. Now here you can see, get the picture, already you drawn that flow chart in your left side of pages of your copy. So here it is a crystalline and amorphous. Already I told you, crystalline that have a particular shape, amorphous which do not have any particular shape. In the case of amorphous, like carbon, coke and charcoal are coming, which we already studied in the junior classes like 6 to 8. So in this chapter we are just going to discuss about the crystalline amorphous. Clear? Now when we talk about the diamond, you have seen that diamond में क्या था, 3-dimensional structure है. Each and every carbon atom is attached with the nearest 4 carbon atom, and it has a tetrahedral fashion pattern. Okay, and the hybridization is sp3. Fine. Again reminding it to you, it has a very hard in nature, and it is a very bad conductor of electricity. Now when we are talking about the diamond, you can see the picture, you can see the diamond here. ठीक है, तो डायमंड में अगर आप देखते हो, इट हैज़ अ लेयर्ड स्ट्रक्चर एंड इट हैज़ अ बेसिकली हाइब्रिडाइजेशन इज sp2. In the case of diamond the hybridization is sp3, but in the case of graphite the hybridization is sp2. Each carbon is bonded to the 3 carbon atom through a sigma bond, and there is one pi bond. So sigma bond means there is a single bond, 3 single bonds are there. Pi bond means there is one double bond between one carbon atom. So that's why the valency of carbon atom is balanced, and there is one free electrons are also there. So that's why the graphite is a very good conductor of electricity. Fine. Next is the fullerene. This is the, you can see the picture of fullerene, and this is the ball like structure. Okay, so you can say this is the cage like structure or a soccer ball like structure. Okay, it is called Buckminster Fullerene because of the name of the architect. Okay, all the carbon atom in that is also a sp2 hybridized. Okay, and it has both single bond and double bond present to balance the valency of a carbon atom. So this is the fullerene, and this is the allotrope which we already discussed. Now what is your work today? The work is that, first of all, you have done that diamond, you have written about the diamond in your classwork copy. Today you have to write about the graphite and fullerenes in your classwork copy, and the activity which you have done in the last 5 months, like one activity which I have given it to you, you have to make the PowerPoint presentation. The second is that you have to write about the drugs of coronavirus. Okay, so you have to send the PDF to me, so I will give you the marks according to that, those who haven't sent. Fine. So this is your work of today, do it.